In this video, we'll continue our discussion of the double angle identities and sum identities. We're working right now on our sum identities. This problem looks very daunting. I think when I first started teaching this trig a while back, teaching trig, I was very, I would always get held up on here, and it's easier than it seems. Okay, so what we're going to do, let's focus first on just this, inverse cosine of 1/2. Now remember, when I have just cosine, when I just have a cosine, I plug in an angle and I get a value, right? That's what that's saying. I'm not going to try to figure out what inverse cosine of that angle is, and you'll see why. I'm just going to acknowledge that the answer to that highlighted problem is an angle. So that's actually equal to A. So I'm going to call that angle A, and then we're going to use a right triangle to be able to evaluate that. Remember, cosine is CAH, caught another hippie. So from that angle, I have adjacent, which is 1, over hypotenuse, which is 2. Or I could even do it this way. Okay, I could say cosine is the x value, so that's 1/2 over 1. I think that may be a little easier for us. Also, we're used to the other value for this triangle. We have 1, 1/2, and then the other value is going to be radical 3 over 2. So anytime I see that half or radical 3 over 2, I'd like to do my triangles like this. It's much easier. Okay, so now we're going to focus on the other angle. So this angle being our inverse sine of 3/5, the answer to that is, we'll call it B. The answer there is B. And then cosine, remember, sine, some old hippie. So it's 3, and this one I don't put 3 over 5 over there because that isn't my unit circle. 3/5 is not on it. And then this makes this very easy. That third side is one of my Pythagorean triples, 3, 4, 5. You could also use Pythagorean identity there to find those Pythagorean theorem to use to find those sides. So now what I'm going to do is I'm going to say, hey, this is equal to sine of, okay, remember the answer to that inverse cosine is the angle A. The answer to my inverse sine is B. Okay, and then now I use my sine formula that we've been using in this section. So it's going to be sine of A times cosine of B plus sine of B times cosine of A. We just have to plug those in. Now, I don't actually have an angle to evaluate, but I can use my triangles to find this. So sine of A is using my A triangle right up here. And the sine of that angle, okay, would be radical 3 over 2. That's y over hypotenuse. So it's radical 3 over 2. Cosine of B, that's this triangle. Cosine is adjacent over hypotenuse, so it's going to be a 4 over 5. Plus sine of B, that's that same triangle that we were just looking at. And the sine of that B is 3 over 5. And then cosine of that A is going to be 1 over 2. That's just using each triangle. So this ends up being, okay, well, we get this 4 and that 2. There's 1, 2, and 2, 2 2's and 4. So this is 2 rad 3 over 5. Plus, and this is going to be 3 over 10. That's a great answer. If you guys wanted to go to a common denominator, I mean, I guess I would have just not canceled what I did above. So I could say, okay, that's going to be 4 rad 3 over 10 plus 3 over 10. And I could add these together. It doesn't really make it feel any simpler. I can't add 3 and 4, so please do not do that. Kind of like our quadratic formula ends up looking like. So you could stop here, or you could stop there. Either way, both are great answers to me. It really just depends if you're plugging it into your homework software or if you are doing it on a test. On a test, I would stop the first place I can get to like that, where I have no more trig to figure out. That's where I would stop to make sure I don't make any mistakes.